If we increase the temperature here, we might achieve a higher molecular weight.
Okay. Look at the uniformity of the filament, Wally. It's quite remarkable.
December 1941. A cold wind moves across an American airfield just before dawn. Engines sit silent. Canvas covers ripple slightly in the dark. Inside a low wooden building, hands move slowly over folded fabric. Every seam is checked. Every stitch is felt, not seen. The parachute is light, almost fragile, yet a man's life depends on it. For decades, this fabric would have come from one place. Raw silk, grown, spun, and shipped across oceans now dominated by an enemy. But tonight, the material beneath these fingers feels different. Smoother, tighter, artificial. No one in the room calls it experimental. No one calls it new. There is no time for doubt. Pilots will climb into aircraft in minutes. Some will not return the way they left. Above them, the sky is indifferent. Below them, the ground waits patiently. Between the two hangs a quiet question. Can this unfamiliar fiber hold when silk no longer exists? That question was not born on this airfield. It began years earlier, inside laboratories, factories, and boardrooms, long before America realized it had a fatal weakness woven into its war plans. Before the first American bomb fell, before the first U.S. paratrooper stepped into the night sky, the war had already exposed a silent vulnerability. It was not steel. It was not oil. It was fabric. For generations, military parachutes were made from silk, not because it was fashionable, but because it worked. Silk was light, strong, flexible, and reliable under sudden stress. It packed tightly. It opened cleanly. When a man fell from the sky, silk slowed him gently enough to survive. By the late 1930s, there was no substitute. Every major air force relied on it. Every emergency descent depended on threads grown thousands of miles away. The United States did not produce silk. It never had. American parachutes, balloon envelopes, powder bags, signal flags, and insulation materials all relied on imported raw silk. Nearly all of it came from East Asia. And by the late 1930s, one nation controlled that supply almost completely: Japan. This dependency had been known for years. Trade reports had warned of it. Naval planners had noted it quietly. But silk had always arrived. Ships crossed the Pacific. Warehouses stayed full. The risk remained theoretical. Until it wasn't. As Japan expanded across China after 1937, silk production and export routes fell increasingly under Japanese control. By 1940, the U.S. military found itself dependent on a strategic material sourced almost entirely from a potential enemy. At the same time, air warfare was changing rapidly. Aircraft were flying higher and faster. Combat ranges were expanding. The number of trained pilots was growing, but so were losses. A parachute was no longer optional equipment. It was a necessity. In Europe, the lessons were already clear. Luftwaffe pilots relied heavily on parachutes during the Battle of Britain. British aircrew survival rates depended on them. The Germans, British, and Japanese all understood that a trained pilot lost was harder to replace than an aircraft. The United States understood this too, but preparation lagged behind reality. In 1939, the U.S. Army Air Corps was still small. Budgets were limited. The assumption was that existing stockpiles would be enough until alternatives could be found if needed. Silk imports continued. The urgency remained distant. Then global shipping began to fracture. As war spread across Europe in 1939 and 1940, merchant fleets were redirected, sunk, or seized. Insurance costs soared. Routes narrowed. Strategic materials became bargaining chips. Silk, light and valuable, became harder to move. Meanwhile, American air doctrine was evolving. Parachutes were being standardized across bomber and fighter crews. Training accidents made their necessity undeniable. Reports from Europe confirmed what tests already showed. Without reliable parachutes, air power bled men faster than factories could replace them. Yet there was no American answer to silk. Cotton was too heavy and weak. Wool absorbed moisture. Rayon lacked strength. Early synthetic experiments existed, but none had been proven at scale for life-saving equipment. The risk of failure was unacceptable. As late as 1940, U.S. planners still believed silk supplies could be maintained long enough to transition gradually. But geopolitics was moving faster than industrial caution. In July 1941, the United States froze Japanese assets. Oil and material embargoes followed. The Pacific tightened. Silk shipments stopped. Almost overnight, the theoretical vulnerability became a practical emergency. Warehouses that once felt secure now looked dangerously finite. Training programs expanded just as supply collapsed. Aircrew numbers rose while parachute material disappeared. There was no battlefield yet. No headlines. No casualty lists. But the clock had started. And somewhere inside American industry, a solution existed, unfinished, untested, under fire, and never meant to carry men out of the sky. That solution would have to be ready before the first real fall. The answer to America's silk problem did not come from the military. It came from chemistry. Long before war dictated urgency, American industry had been chasing a quieter ambition: the creation of artificial materials that could rival nature itself. Among the companies leading that effort was DuPont. By the early 20th century, DuPont was no longer just an explosives manufacturer. It had become a scientific institution. Chemists worked alongside engineers. Research budgets were protected even during economic downturns. Failure was expected. Discovery was not rushed. In the 1930s, one of those researchers was Wallace Hume Carruthers. A brilliant organic chemist, Carruthers was not thinking about war. He was thinking about molecules, how long chains of atoms could be linked together to create entirely new substances. At the time, polymer chemistry was poorly understood. Natural fibers like silk and cotton were complex biological products. Artificial fibers existed, but they were limited in strength and consistency. Most were chemically modified natural materials rather than true synthetics. Carruthers pushed further. In 1935, his team created something unprecedented: a fully synthetic polymer fiber. It was strong, elastic, resistant to moisture. It could be melted and drawn into long, uniform threads. DuPont named it nylon. Initially, nylon was a commercial curiosity. Its first public use came in toothbrush bristles, then women's stockings. Lightweight, durable, and smooth, nylon entered American life quietly, marketed as modern convenience rather than strategic necessity. No one advertised it as a replacement for silk, but inside DuPont laboratories, its properties were measured carefully. Tensile strength, elastic recovery, abrasion resistance. Chemists noticed something familiar. Nylon did not behave like cotton. It did not behave like rayon. It behaved like silk. When stretched suddenly, it absorbed energy without snapping. When woven tightly, it carried load evenly across fibers. It resisted moisture better than natural threads. And crucially, it could be produced domestically in enormous quantities from coal, air, and water. The military took notice slowly. Early testing of nylon for parachutes began before the United States entered the war. Engineers were cautious. Parachutes were not stockings. Failure meant death. Every test jump was scrutinized. Fabric weaves were adjusted. Stitching methods reworked. Packing behavior analyzed. Nylon's biggest advantage, its smoothness, was also a problem. Early parachutes opened too quickly. Shock loads were dangerous. Modifications were needed to slow deployment and distribute stress. Time was the enemy. After Pearl Harbor in December 1941, hesitation vanished. Silk imports were gone. Aircrew training surged. New airborne units were forming. The U.S. Army needed parachutes now, not in 5 years. DuPont was ordered to scale nylon production beyond anything attempted before. Chemical plants expanded. New spinning facilities were built at breakneck speed. Engineers rewrote processes as they went. Quality standards tightened even as output exploded. This was not theoretical science anymore. It was wartime engineering under pressure. By early 1942, silk was officially reserved for uses where no substitute yet existed. Nylon was pushed forward into roles once considered untouchable. The gamble was clear. If nylon failed, men would die in the air. If it succeeded, America would free itself from a material dependency that could have crippled its war effort. The decision was not dramatic. No speech announced it. No ceremony marked the change. But in factories and testing fields, the fate of thousands of future airmen was being decided one fiber at a time, just as the war itself was beginning to demand proof. That proof would not come from laboratories. It would come from people, machines, and moments where nylon would be forced to answer the same questions silk had answered for centuries. For the men who wore them, parachutes were not symbols of innovation. They were last chances. A pilot climbing into a cockpit in 1942 did not ask about polymer chains or tensile ratios. He checked straps. He tugged webbing. He felt the weight on his back and memorized its presence. Once airborne, the parachute disappeared from thought until it didn't. Bailing out was never planned. It was a reaction. Fire. Structural failure. Loss of control. Seconds mattered. When a man pulled the ripcord, he surrendered control to fabric. Silk had earned trust through generations of use. Nylon had not. Early on, many aircrew did not even know their parachutes were synthetic. They were told they met standards. That was enough. The military understood something important. Confidence saved lives. Doubt killed before gravity did. Reports from training jumps showed no difference in survival. Nylon held. Openings were adjusted. Failures were rare and investigated aggressively. Each successful descent quietly built faith. For paratroopers, the stakes were even higher. They did not fall alone. They jumped in groups, often at night, often under fire. A single equipment failure could cascade into collisions, entanglements, deaths. Yet nylon performed. Men landed hard but alive. Canopies resisted tearing on trees and buildings. Moisture from rain and fog no longer weakened the fabric. In ways silk never could, nylon endured abuse. Trust did not come from promises. It came from landings. And with each safe recovery, the question shifted from can it work to how did we ever rely on anything else? That shift rippled outward to the factories where the fabric was made and to the industrial systems straining to keep pace with the war. DuPont's challenge was not invention. It was volume. Producing nylon in laboratory quantities was one thing. Producing enough for a global war was another. Parachutes alone required thousands of tons of fiber. Each bomber crew needed multiple chutes. Training consumed more than combat. Factories expanded at wartime speed. New chemical plants rose alongside rail lines. Power, water, and raw materials were diverted under government priority orders. Production schedules were measured in hours, not months. Every spool had to be consistent. Every fiber uniform. Variations that were acceptable in consumer goods were unacceptable in life-saving equipment. Engineers worked around the clock. Processes were redesigned mid-production. Quality inspectors rejected entire batches without hesitation. The pressure was relentless. Failure did not mean lost profit. It meant grounded aircraft. Yet the system held. Output climbed. Nylon moved from scarcity to standard. Silk disappeared from supply lists. What had once been a vulnerability was becoming an advantage, provided the science beneath the fabric continued to justify the trust placed in it. That justification rested in the chemistry itself. Nylon's strength came not from biology, but from order. Where silk relied on proteins spun by insects, nylon relied on molecular alignment. Long chains of atoms were drawn and stretched, locking into patterns that distributed stress evenly. Under sudden load, the chains elongated rather than snapping. This gave nylon a critical advantage: predictability. It did not rot. It did not weaken when wet. Its behavior could be engineered. Opening shock could be tuned through weave density and canopy design. Failure points could be tested and eliminated. For the first time, parachute material could be controlled at the molecular level. This was not just replacement. It was transformation. And as these advantages became clear, planners began to see nylon not as an emergency substitute, but as a platform for something larger. A realization that would shape military thinking far beyond parachutes and far beyond 1942. For military planners, nylon changed the equation in ways that went beyond survival equipment. Silk had always been fragile as a supply line. It required land, climate, labor, and shipping routes that could be disrupted by weather, diplomacy, or war. Nylon required factories, facilities that could be guarded, expanded, and supplied domestically. This shifted planning from dependence to control. Training schedules no longer had to be balanced against fabric availability. Parachutes could be issued more freely, replaced more often, and improved continuously. Stockpiles could be built in advance rather than rationed. Nylon also simplified standardization. Different aircraft types no longer required different silk weaves sourced from varying suppliers. A single industrial base fed the entire system. By 1943, nylon parachutes were no longer labeled experimental. They were regulation equipment. The Army Air Forces could expand without hesitation. Airborne divisions could be equipped without compromise. Material uncertainty, one of war's quiet killers, was removed from the equation. That certainty forced a second realization. If synthetic fibers could replace silk, what else could they replace? Before 1941, Japan's control over silk production gave it leverage few openly discussed. Silk was not glamorous. It did not dominate headlines, but it was indispensable. When the United States severed trade, Japan expected shortages to weaken American readiness. In some areas it did, but nylon erased that advantage. By removing silk from the strategic equation, the United States neutralized a pressure point without firing a shot. Japanese industry continued producing silk for its own military, but the export power that once mattered vanished. This was not battlefield defeat. It was irrelevance. Synthetic fibers denied the enemy an economic weapon, and they did so invisibly, without propaganda, without ceremony. The war moved on, but the balance had shifted quietly, permanently. For the scientists and engineers behind nylon, the war changed the meaning of their work. Before 1941, nylon was progress. After 1941, it was obligation. Chemists who once measured yields now read casualty reports. Engineers who adjusted spinning speeds understood that errors meant funerals. The distance between laboratory and battlefield collapsed. There were no speeches about heroism, no medals for polymer chains, but responsibility weighed heavily. Nylon did not end the war. It did not choose sides, but it carried men safely out of burning aircraft and into uncertain futures. That reality forced a new relationship between science and war, one where innovation could not hide behind neutrality. And as nylon moved from factories into combat zones, it would soon face the only test that mattered, the moment when theory ended and falling began. By mid-1942, nylon no longer lived in reports or test fields. It lived in the air. The U.S. Army Air Forces were now flying sustained combat operations. Bombers crossed long distances over hostile territory. Fighters pushed deeper, faster, and higher. Losses were inevitable. Bailouts were no longer rare events. They were expected contingencies. Every one of those moments tested the same thing. At altitude, air temperature dropped below freezing. Canopies stiffened. Lines snapped tight. The shock of opening multiplied by speed and gravity. If nylon failed, there would be no second chance. The first real test came without announcement. Over Europe, damaged bombers lost engines to flak. Over the Pacific, fighters burned after surprise interceptions. Pilots pulled ripcords and fell into chaos. And nylon held. Reports filtered back slowly. Not dramatic, not celebratory. Simple observations. Canopy opened normally. Descent rate acceptable. Fabric intact after landing. No unusual tearing. Failures still occurred, but they mirrored silk era statistics. Manufacturing defects. Packing errors. Human mistakes. Nylon itself was not the cause. This mattered. Military acceptance does not come from success alone. It comes from no new failures. Nylon was not better because it was new. It was better because it did not introduce new risk. As confidence grew, deployment widened. Training units received full nylon equipment. Older silk reserves were phased out. Paratrooper jumps increased in scale. One of the most demanding tests came from airborne operations. Mass drops where hundreds of men exited aircraft within seconds. Canopies collided. Lines tangled. Shock loads stacked. Nylon endured the violence of the air. Its resistance to moisture proved decisive. Rain and sea spray no longer compromised strength. Storage life extended. Maintenance simplified. The fabric behaved the same in England, North Africa, and the Pacific. Behind the scenes, data was collected obsessively. DuPont engineers reviewed every incident. Military inspectors updated specifications. Minor adjustments improved performance further. This was not triumph. It was validation. The war did not pause to acknowledge it. Aircraft kept flying. Men kept jumping. But a silent threshold had been crossed. Synthetic fiber, once an emergency substitute, had proven itself under conditions nature itself had never designed for. And now, nylon would face its most unforgiving environment yet. Combat at scale. Late 1942 and early 1943 marked the true baptism for nylon parachutes. In North Africa, American paratroopers prepared for Operation Torch. Night drops over unfamiliar terrain tested every aspect of airborne training. Visibility was low. Winds shifted without warning. Enemy fire waited below. Thousands of men depended on fabric that had existed for little more than a year. Aircraft roared, wings trembling with load. Pilots and jump masters checked gear one last time. Ripcords clicked. Heartbeats accelerated. Then the jump. Paratroopers fell into the night. Canopies inflated. The air filled with the sound of whipping nylon. One by one, men descended safely. Lines held. Canopies resisted tearing against branches and rocks. Landing zones absorbed dozens of men without catastrophic failure. Every successful landing reinforced a simple truth. Nylon worked. It did what silk had done for decades, and in some ways, it did more. It could be mass-produced. It could endure environments silk could not. And most importantly, it saved lives. Across the Pacific, the story repeated itself. Aircrew forced to bail out of bombers after damage or fuel depletion found nylon parachutes reliable. Reports emphasized its resilience to rain, humidity, and the heat of tropical climates. Pilots who might otherwise have perished landed safely, often behind enemy lines but alive. The industrial machine had met the battlefield. DuPont's plants churned out more nylon than anyone had expected. Factories operated day and night, workers aware that each spool could be the difference between life and death. By mid-1943, nylon parachutes were standard issue. Silk was now a backup, reserved for specialty items. The U.S. had eliminated a critical strategic vulnerability without a single combat loss, due solely to fabric failure. This silent victory reshaped planning. Paratroopers became a more confident, aggressive force. Air missions could rely on emergency recovery as a realistic option. The psychological impact was profound. Men trusted their equipment. Lives were preserved, morale improved, and the strategic calculus shifted. Nylon had become more than a substitute. It had become essential. What had begun as a laboratory curiosity now defined airborne warfare, domestic industrial capability, and strategic independence in a single, unassuming thread. And as the war continued, the story of nylon would expand, touching industries, economies, and everyday life. But for now, on those battlefields, it had proven itself where it mattered most, under pressure, in the air, holding men against the sky. By 1944, nylon had moved from emergency experiment to cornerstone of American military logistics. Factories were producing parachutes at an unprecedented scale. Millions of yards of nylon flowed from spinning plants to assembly lines, then to airfields around the world. Each parachute packed, inspected, and crated carried not just a soldier's life, but a demonstration of industrial mastery under wartime conditions. The effects were immediate. Airborne divisions could now plan larger operations without hesitation. The 82nd and 101st Airborne Divisions in Europe trained relentlessly, confident that their equipment would survive even the most chaotic night drop. Casualty rates from failed parachutes, which had once been a hidden concern, disappeared from operational reports. Lives that might have been lost to silk shortages were now preserved. But the impact went beyond survival. The military realized that dependency on imported raw materials was not just inconvenient, it was dangerous. Nylon proved that innovation could replace vulnerability. Silk, once considered indispensable, became obsolete almost overnight. What had been a logistical weak point was now a symbol of strategic independence. The success of nylon parachutes also encouraged further experimentation with synthetic materials. Cotton and rayon had limitations. Nylon had opened the door for other fibers to enter military service, from ropes to tents to life-saving equipment. Science and industry had stepped directly into the theater of war, reshaping what was possible in months rather than years. And yet, the victory remained largely invisible. There were no headlines proclaiming nylon as a savior. Its contribution was measured in survival reports, in successful drops, in lives that returned to fight another day. For many, the war continued as it always had, unaware that a synthetic thread had quietly redefined the boundaries of survival and combat. The story did not end there. While the war raged, the groundwork for post-war transformation had already been laid. Nylon success would ripple far beyond parachutes, touching civilian life, industry, and even fashion. But for the men in the air, its immediate impact was singular. It worked. It saved lives. It held onto the sky when it mattered most. As the war progressed, nylon's influence extended far beyond the immediate battlefield. Its success in parachutes validated synthetic fibers for other military applications. Tent fabrics, ropes, cargo nets, and life vests increasingly relied on nylon. Soldiers on multiple fronts benefited from gear that was stronger, lighter, and more durable than its natural predecessors. The strategic consequences were profound. By replacing silk, the United States had removed a critical vulnerability from its supply chain. Enemy leverage, once concentrated in faraway, silk-producing regions, had vanished. The military no longer faced the constant anxiety of disrupted shipments or scarce materials. Airborne operations could be scaled up with confidence, and planning became more flexible. The war machine had gained both efficiency and resilience, invisible to those outside logistics and procurement offices, but decisive in outcomes on the ground and in the air. Post-war, Nylon's legacy extended into civilian life. Factories that had expanded rapidly to meet wartime demands now turned to consumer products. Nylon stockings became a symbol of modernity. Tents and ropes entered civilian camping and outdoor markets, and the polymer revolution quietly transformed industries across the country. The synthetic fiber that had once carried men safely through enemy fire now carried the weight of peacetime progress, linking wartime innovation to everyday life. Yet the moral and human dimension remained. Every successful nylon parachute jump was a testament to the collaboration between science, industry, and military foresight. Lives that could have been lost to silk shortages were preserved. Each safe landing reinforced the trust in human ingenuity under pressure. Nylon had become more than a material. It was a bridge between survival, technology, and strategy, demonstrating how careful planning and innovative thinking could turn a critical weakness into a silent advantage. The war moved forward, and history often remembers battles, generals, and victories. But beneath those narratives were threads like nylon, small in appearance, but vast in consequence, shaping the course of lives and the efficiency of armies. By 1945, synthetic fibers were no longer just a wartime necessity. They were a permanent transformation in how humans understood and applied material science in times of conflict. Nylon parachutes did not make headlines. They did not win battles with gunfire or strategy. Yet, in the quiet spaces between plains and sky, they rewrote the rules of survival. A single thread, spun in a laboratory far from combat, carried men through fire and storm. It transformed dependence into independence, scarcity into abundance, and doubt into trust. In its fibers, chemistry met courage, and industry met necessity. The lesson was simple but profound. Innovation can be as decisive as courage on the battlefield. Materials, often overlooked, can shape strategy, influence morale, and determine who survives the fall. Nylon was more than a substitute for silk. It was a lifeline, a symbol of how science could safeguard human life, even in the most extreme circumstances. When the war ended, the soldiers who had trusted nylon carried its quiet legacy with them. Factories shifted to peacetime production, civilians embraced its conveniences, and the military retained the knowledge that survival sometimes depends on ingenuity as much as skill. In the air, on the ground, and across decades, nylon remained a testament to foresight, preparation, and the invisible threads that hold history together. One material, carefully engineered, had changed the course of lives, and quietly, the course of war itself.